Chilling? Very calm and sedate today. All right, let's get through the lecture. We've got maybe 15, 20 minutes tops. If we're rolling, we're going to finish out the last of the trig section. Today we're going to be talking about tangent. We've done sine, we've done cosine. It's tangent's turn. So make sure that you've got a hero nearby.
Opposite or adjacent?
Oh my goodness, did you already go to your notes?
No, just obvious that both have the opposite.
You went to Sokotoa, didn't you?
Yeah.
Yep. Did the song pop into your head?
No, I started it.
You just started dancing. That's awesome. As the song was helping you say, helping you remember, SOH, so is sine opposite hypotenuse. Ka, cosine adjacent hypotenuse. Toa, tangent opposite adjacent. All right, let's go ahead and go right into the examples for the day. First example comes to you from page 136. And it'll help you with questions 16 through 18. I want to update you. On this page, only do the first 6 questions. Only do 13 through 18. Okay?
Wait, what makes it
Because I don't have 136.
On page 137,
Okay, never mind.
only do 13 through 18.
Wait, it was 16.
Yeah, this will help you with 16 through 18, but only do 13 through 18. I'm going to do another example on the bottom of the page to help you with 13 and through 15. Don't scratch out the bottom of the page yet. We will come back to it. You will need to be able to do it later, so leave it open and blank. But for right now, all you need to do is 13 through 18. All right, let's go on with our first example. Please draw me a right triangle on your paper. You can make him kind of big. Take about half of your workspace.
So,
Yes.
hold on, so can your email and reply to that so I can get back to the parent, please?
Yes, ma'am. I'd like you please to give me the measure of an acute angle.
That's right.
Give me the measure of acute angle. 60? Okay. Yeah, and basically any number you gave me that was less than 90, totally is the right answer. Because an acute angle is anything less than 90. Fantastic. Give me a letter for a variable, please.
V.
B.
I said V.
Oh, I heard, okay, V. I can change it. Don't be hating, I can change it. And now I need a number for the side length. Any number you like.
65.
65, I heard? Or did you have a number over here? No? Okay. All right, here it is. And the directions say, use the tangent ratio. Let's spell that right. To find the value of V. Round to the nearest tenth. That's 1 decimal place. All right, so let's go ahead and start with our generic tangent ratio, which from the top of your notes is Sokotoa. Tangent theta is
Opposite.
over
Adjacent.
adjacent. Notice how I'm abbreviating. All right, let's fill in what we know. The tangent of 60 degrees equals, use your skills from finding the opposite side when we were doing sine to find the opposite side now. It's the same skill. Use the skill that you learned when we were doing cosine to find the adjacent side.
V.
Nicely done. Use your superhero to please give me the decimal notation for the tangent of 60 degrees. Get your superhero, go to the trig menu. It's by the number 7 button. So you can get some practice doing it. 60 degrees. To 4 decimal places, go. Never mind. Okay, fix it. Make it sure it's tangent. Tangent is 60 degrees. What was it? 1.73. Confirm?
Yeah.
Yes? One more confirmation. Got a nod from across the room. Lovely. Alrighty. Ooh, come back, pen. Pen's away. So is my little son. Give me a second. We're going to cross multiply here. 1.73v equals 65. I want to get v all by itself. What do I do to make that happen? Multiply or divide?
Divide.
Divide by what?
One.
The 1 point something? Yeah. Divide by 1.73. All right, give me that number. Round to the 10th decimal place. 1 decimal place only. Go.
37.60.
37.6. Awesome. Thumbs up. Finding and using tangent. Totally easy. Thumbs sideways. You could do it, but you want your notes. Thumbs down, you're completely lost. Vote now. If you don't vote, I'm going to start to. Thank you, sir. I'm going to assume that it's a thumbs down. So vote now. Thumbs up, totally easy. Sideways, you want your notes.
My thumbs up.
Your thumbs up. Your thumbs up? Awesome. Okay, I see it. Thank you. I did get a couple of thumbs down. I will be with you shortly after lecture to help you, okay? Okay. Okay, let's do the final example for the day. This is from page 137. This example will help you get through numbers 13 through 15. And in fact, this is question number 13. Here are the directions. For acute angle A of a right triangle, find tangent A using 45, 45, 90, and 30, 60, 90. Let me fix this. It's an or. Very sorry. Okay, and all you are given is the measure of angle A is 30 degrees. That's all you're given. Well, that's not helpful. You know what? Let's draw a picture. See if that helps. We know this is a right triangle, so draw a right triangle for me, please. You can make it as big or as small as you want. You've got plenty of space. You can use the rest of your paper. We're going to put a right angle. We're going to name one of our angles A and make its angle measure 30 degrees. All right. We still don't have any side measures, do we? Which we need because if you look at your generic tangent of any angle theta, from the top of the page, that ratio is the opposite side over the adjacent side. I don't have either of those. But I do have that this is a 30-degree angle. And if we recall from last Thursday, which is the 11th of September, back on the notes, the lecture that was titled Special Right Triangles, we had a 30, 60, 90 right triangle. And this right triangle had a special relationship between the measures of its sides. Copying from last Thursday notes, this was the relationship that we were given. So I can basically, at this point, make up any numbers I want. And as long as they match this pattern, I put them here, I'm good. Any numbers you want, as long as they match this pattern, they go here. And it's a little scary because what if your numbers are wrong? And how do you know? And suddenly you start getting nervous, right? Right. Relax. Let's make it easy. Let's start with this one. It's just got an X. That means I can make that any number I want. If I look at these other sides, I see that I'm multiplying whatever number I've picked by these other numbers, yes? Which means I probably want something that's really easy to multiply with.
1.
1 is a super easy number to multiply with. Why is it so super easy? Because anything times 1 is itself. 1 times 1 is? 1 times 2 is? 1 times 3 is? 1 times a million is? A million. 1 times the square root of 3 is?
Square root of 3.
Cool, you guys are super smart. Look at that.
I actually felt that way. You told me like that.
You're amazing. That was phenomenal. And now we have a side opposite and a side adjacent. And we have our ratio. And everyone's happy, except one group of people.
Who?
The people who invented all these weird squiggly things we use to write math in. Because a long time ago, when they were deciding how the squiggly things were supposed to look, they decided that fractions should never ever have the casita in the bottom. Radicals shouldn't go in the denominator. There's a process to simplify them. The process to simplify radicals in fractions is rationalization. Which is something that I will teach you on a separate occasion, because for today, and to prep you for that CBA tomorrow, I don't want to force you to have to learn and practice a brand new skill like this. Okay? So we'll do it another day to prepare you for Algebra 2, in which you're going to be doing lots and lots of these. You will do it a little bit in this class with some of the things that are going to come up soon. So I want to get you ready and have some practice for it, but not today. All right? Sound fair enough? Yep. And we're done. You guys are awesome today. Do you want to give yourselves a round of applause? Because you guys are awesome? Go for it. You deserve it. Scattered up.